So give the heading as climate change. Let's cover that. Because I don't want to skip. Anyhow, we are in climatology. We can cover a topic called climatology. Climate change. Climate change. Okay. See, you should know what the word climate means. Long term average of weather is climate, correct? What is weather? Short term conditions prevailing over a place. What you feel now is weather. If you take average of weather for a very long time, that is called as climate. Okay. So the climate of the earth, what we have, has been evolving just like the evolution of earth. Since the formation of earth till now, how earth is evolving, earth is changing, the climate of the earth also has been changing. So climate change is nothing new. It's a constant phenomena. So only thing is how the climate change is occurring, because of whom the climate change is occurring. That is what is affecting us now. So what I'm trying to say is the change in climate, what we are noticing on the earth right from its formation till now, is natural phenomena. Okay. Only thing is we are the one responsible now. Humans are being held responsible for the present climate change. That is the reason it is affecting us now. You'll understand that the climate change has two components here. One is, please write, global warming, global warming, global cooling, global cooling. Okay, two aspects, global warming and global cooling. Everybody is talking about global warming. Nobody is talking about global cooling. But there is one concept called global cooling also. Because before we came to this global warming phase, we were in ice age. For a very long period of time, earth was in ice age. Everywhere there were glaciers. Correct. Now because of the increasing carbon dioxide in our atmosphere, we have entered warming phase. Otherwise, till 10,000 BC, we were in ice age. Ice age actually. Okay. How global cooling occurs, we'll discuss now. Okay. In one of the topics we have discussed Pacific Ring of Fire. All of you know Pacific Ring of Fire? Pacific Ring of Fire has around 1,000 volcanoes hai yahan pe. There are how many? 1,000 volcanoes here. As of now, 50 of them are active. 50 of them active. So the volcanoes, imagine all 1,000 of them go active now. So what will happen? All volcanoes will release large amount of pyroclastic material. Pyroclastic material will be released into the atmosphere. Imagine our entire atmosphere will be full of gases, ash, dust, smoke. For many days we will not see the sun. Sunlight will not reach us. You got it? So the volcanoes, if all of them erupt at once along the Pacific Ring of Fire, our entire troposphere will be clogged with smoke and dust, blocking sunlight for many days. As soon as that happens, what happens? Our troposphere is full of dust and smoke and gases. These gases will cause acid rain. I'm talking about gases like sulfur dioxide, nitrogen dioxide. Correct. These gases will react with water in the clouds, bring acid rain. So first few days there will be heavy acid rain across the planet. Then the smoke and dust will choke most of the people and animals. Smoke and dust. Because we will not have clean air to breathe. We will not have clean air to breathe. Everywhere there will be smoke and ash and dust. So as a result, this will choke us. Then no sunlight is reaching the ground, means plants die. Because no photosynthesis means what? In 1 week all plants will die, crops will die. Even if some people survive, they also start dying slowly because of lack of food. Correct. So within few days, the entire planet Earth will cool. Because no sunlight is reaching. As a result, planet Earth starts cooling. Because no insulation. Because the only source of energy for us is what? Sun. So no sunlight means what? Entire planet will cool. So when the planet cools, here notice this, temperature comes down. When the temperature comes down, what happens? We'll enter global cooling phase. So that is called as nuclear winter. Nuclear winter. So that means the volcanoes on Earth can push us back to global cooling. So all the life on Earth will go extinct. That is called as nuclear winter. So please remember this. So one aspect of climate change is nuclear winter. So the Pacific Ring of Fire and the volcanoes here can push us back to global cooling phase and nuclear winter by adding a lot of pyroclastic material into the atmosphere, which will result in acid rain, smoke and dust can choke most of the animals, plus no photosynthesis because sunlight will be blocked. Sunlight is blocked. So crop failure, plants die. So slowly all the life will go extinct. Temperature of the earth comes down. Water will freeze. Correct. Water will freeze now. Surface water like lake, rivers. Surface water will freeze, forming ice. So as a result, most of the life will go extinct. So that is called as global cooling. So this is one aspect of the climate change. Okay, that is clear. Now I'll come to this global warming part. This has two segments: natural, man-made. Natural, man-made, or anthropogenic. Can I use the word anthropogenic? Anthropogenic. Global warming, anthropogenic. Other one is natural. Natural has two segments again. Or we can write cosmogenic climate change, terrestrial climate change. Terrestrial. Cosmogenous or cosmogenic? I'll use the word cosmogenous. So related to space, cosmogenous means like our stars, the amount of energy we receive from sun. Okay. So we'll start from this cosmogenous, then terrestrial, then anthropogenic. Okay. This, some authors use it as extraterrestrial also. Okay. This is also called as extraterrestrial. In case if you don't want to write cosmogenous, I can use the word extraterrestrial. Extraterrestrial. So global cooling can become a question in mains. What is global cooling? What is the impact of global cooling on Earth? And the resulting extinction of life is called as nuclear winter. Okay. So start from extraterrestrial part. Okay. I'll go to next page. See, in our starting class, we were discussing something about nebula. Remember? Nebula is a large cloud of gas and dust. Cloud of gas and dust. In our NCERT class, we had discussed this. So initially we had everything in the form of a nebula. All the gases, dust were in the form of nebula. Cloud of gas and dust. The most abundant gas, I told you, was hydrogen. Even today, most abundant element in the universe is hydrogen. Okay. So here, all these hydrogen fused to form stars. First was the protostar formed. Protostar was formed like this. I'll take two cases here. Massive protostar and a protostar. All the hydrogen atoms come together to form star. So what is a star? Star is a hot ball of hydrogen gas. Stars are hot ball of hydrogen gas. So these hydrogen atoms fuse to form helium. So during this nuclear fusion, what happens? Large amount of electromagnetic energy is released. So slowly stars become luminous. Stars become luminous because during that fusion process, large amount of energy is released and that comes out in all direction. So stars are hot, luminous celestial objects. They glow because they produce their own natural light through nuclear fusion. So here I am writing protostar means pre-star and then star. Star is formed like this. Okay, protostar and a star. So I'm writing this side massive stars, that side average star I'm writing. Okay, so we'll come back to this diagram. For now, all of you remember nebula means cloud of gas and dust, where we have a lot of dust and gas. Which gas was most abundant? Hydrogen. All these hydrogen atoms fuse to form stars. Okay, star. Let's say we'll take star. All stars are hot ball of hydrogen gas. Stars are hot luminous. Luminous means capable of producing their own light and heat. Hot luminous celestial objects. Celestial objects. Please wait now. Inside the star we have a core. This is where the nuclear fusion takes place. All of you understand fusion and fission. Fission means when atom splits. Fusion is when the atoms fuse. Okay. Nuclear fusion. Nuclear fusion here results in formation of helium. Large amount of helium is formed here and the temperature is 15.5 million degrees Celsius. Such a high temperature mein matter is in plasma state here. Okay. The core contains matter in plasma. The fourth state of matter. Core in plasma. So this energy comes out in all direction as radiation. This is called as radiation zone. This zone is called as the radiation zone. Radiation. Core, radiation zone. As it comes out, matter comes out. What happens? Temperature slightly comes down. So the matter comes to gaseous form. Here it comes out in convection. This is called as convection zone, like this. Convection zone. This layer is called as convection zone. So inside the stars there are three layers: core, radiation zone, convection zone. CRC. Core is inside, radiation zone and convection zone. What are the three layers inside the star? Core, radiation, convection. Okay, because as you go out, plasma state to gases here. So it comes out in form of convection here. This outer layer, what you see, is called as photosphere. The visible portion of the sun that we see every day when you see sun is called as photosphere. Visible portion of the sun. The outer layer of the sun is called as photosphere. So here large amount of energy comes out and that is chromosphere. Chromosphere and corona. Okay, these three are called as sun's atmosphere. Sun's atmosphere. These three are called as sun's interior. So every star will have these three layers of atmosphere, these three layers of interior. Every star around the world. Okay, all stars in our universe have three inner layers, three outer layers. Why are we discussing this? If you understand this, I can talk about what is happening inside sun, how sun will age, all that we can discuss. Sun is initially made up of hydrogen. All stars are made up of hydrogen. So slowly hydrogen fuses to form helium. Correct. So after some time, small stars will start to fuse. Okay. So then suns start growing. That is called as red giant. Red giant phase. As a result, you should know this. First you write this, then I'll go back. What are stars? Hot ball of hydrogen gas. Hot ball of hydrogen gas. First introduction you should know. Stars are hot, luminous, celestial objects. We have done this? Oh, previous. Oh, okay. Yes. This you don't have to write. First you write this. This is done. Write this. Then we'll go back. Because that is one full diagram. So large group of star. Cluster of star. Star is a galaxy. What is galaxy now? You know. Galaxies contain large group of stars. Large cluster of stars is galaxy. Stars are source of light and heat energy. Stars are source of light and heat energy. So what are the three layers inside the star? You know now. Remember in one of the class I have told you about Stefan Boltzmann law. The intensity of radiation emitted by any hot object is directly proportional to the fourth power of its surface temperature. Remember this? Intensity of radiation emitted by any stars is directly proportional to the fourth power of its surface temperature, and I call this as Stefan Boltzmann law. We have discussed this. So sun's temperature is 5800 surface temperature. You put that T here to the power of 4. That means you can get to know how much energy is coming out of sun. Okay. And also I have given you one more equation. The wavelength emitted by any object is inversely proportional to the temperature. This also Wien's displacement law I have given you. Physics we have covered. Correct. Higher the temperature, faster is the vibration of the particles. Faster is the vibration, shorter the wavelength emitted. So the wavelength is inversely proportional to temperature. Higher the temperature, shorter the short wave radiation is emitted. Correct na? Sun emits what radiation? Short wave radiation. That you will come to know from here. Please remember, a lot of physics is here. Temperature high means short wavelength. Low wavelength, X-ray, gamma, UV. These are all short wave radiation. This I'll write here. Wavelength is inversely proportional to temperature. So higher the temperature, shorter is the wavelength of radiation emitted. So high temperature means stars which are higher, hotter stars will emit shorter wavelength radiation. Gamma, X-ray, UV and all. Okay. So chromosphere and corona are not visible. These two are not visible normally. This is what is visible because the light comes from photons. Packets of light energy comes from here. So what is visible to us? Photosphere. Chromosphere and corona are visible only during solar eclipse. When the total solar eclipse occurs, these two will be visible. I'll show you that also. Okay. Otherwise, normally what is visible? Photosphere. Photosphere is the region from where we get packets of light energy called photons. Okay. Photons are emitted by which layer? All of you will, they'll come to know. They'll ask this UPSC prelims. Photons are emitted by which layer? Photosphere. Okay. So we see photosphere. So Aditya L1, all of you know Aditya L1 being launched, already launched by ISRO, is studying photosphere, chromosphere, corona of the sun. Okay. Solar atmosphere. Solar atmosphere. So don't you think sun is formed now? Sun also has some lifespan. Once all this hydrogen is over, what happens? Helium will be there. So if the energy is available, the helium also starts fusing. If it is not available, what will happen? the fusion will stop. Can I go to next page? Okay. So then the star will stop to, it'll fusion will stop, but the size of the star will grow. That is called as red giant. Next stage is red giant. After this formation, here I have reached here. See, this one we have reached. After this, what happens? Once the fusion process stops, the star starts growing. It becomes larger. It is called as red giant. Red giant. Most stars in our galaxy, they'll be initially protostar, then become star, then they will become red giant. So when the fusion process stops, it starts growing. What happens when it becomes red giant? Its gravity increases further because it is full of helium now. Hydrogen core, helium. So the gravity increases. So now what happens? Please notice this. All the outer layers will explode now. Explode. Called planetary nebula. Planetary nebula. It is called as planetary nebula. So many of the planets, inner planets like Mercury, Venus, Earth will go and collide. As a result, so there will be a planetary nebula formation. Only the core will be left now. After this, the core of this will be left here. This is called as white dwarf. After planetary nebula, the core that is left is called as white dwarf. It will be hot. It looks like this. After some time, it will cool. It becomes black dwarf. It becomes black dwarf. So this is the end of our star. This color is visible? No. All right. Color I have written black, but I'll write here here black dwarf. So please remember this. So most stars end up as black dwarf, like our sun. Sun is the average star. So our sun will become like this. Red giant one day, then planetary nebula, all the planets will collide. It will explode, causing only the core to be left. White dwarf, finally black dwarf. Okay. So you don't have to write it now. So I'm just telling you what happens over the period of time. Some massive stars are there in the universe, in the galaxy. They are so huge, they are 100 times bigger than our sun. So those massive stars will become like this. See here, super massive stars. They are called as super massive stars. These massive stars will grow on to become massive red giant or super red giant. Super red giant. Don't worry, I'll explain. You have to remember this. Massive red giant. So this massive red giant also will explode, called supernova. This explosion is one of the biggest explosion ever in the universe, called as supernova. Supernova explosion. Then if the core survives, please here, the core is here. The red giant's core. The red giant's core. If the core survives this explosion, okay. If the core collapses, two things will happen now. Okay. If the core survives, it's called as pulsar. Okay. Neutron star. We call it as neutron star. Please remember this. Pulsar I will write later. Just remember neutron star. Neutron star is a star which has survived the explosion, supernova explosion. The core has survived. If the core collapses under its own gravity, black hole. Now you know what is black hole. So the black hole and a neutron star are formed from a massive stars, supermassive stars. Okay. During the supernova explosion, if the core collapses under its own gravity, black hole. If the core survives, neutron star. Neutron star. Okay. These neutron stars will be emitting pulses of electromagnetic energy like this. They will be emitting pulses of electromagnetic energy once in a while like this, occasionally. So that pulses of electromagnetic energy is called as pulsar. Not the bike pulsar. Okay. This is the pulsars are the neutron stars which emit pulses of electromagnetic energy in the space. So this topic is related to our universe. Okay, so as a result, now I am covering it so that you will all come to know what will happen to our star, sun. What will happen to massive stars in the galaxy. Okay, this diagram we will write later. For now, you should know what happens to star, how the star is formed, you know. There are 7 types of star. Next, types of stars, right? Then we'll go to that diagram. Types of stars. Types of stars. How many types? 7 types. O, B, A, F, G, K, M. So these 7 types of stars are classified based on the spectral emission of each star, because sun is also emitting radiation. Like that, all stars are emitting radiation. That is called a spectral emission. Spectral emission. Based on the spectral emission, we have classified stars into 7 types. This is the most massive star, biggest star in the galaxy, or O type. These are massive stars. These are average stars. This is the smallest. Smallest star in the galaxy is M type. Biggest star in the galaxy is O type. Our sun is, for example, sun is G type star. For your understanding, you should know sun is G type star. What type of star is sun? G type. That means we are neither too small nor too big. So that means there are bigger stars than us. Bigger star than our sun. Okay. So this, our sun's surface temperature is around 5800 degrees Celsius. This one is around 30,000 degree Kelvin. 30,000 Kelvin. Can you imagine 30,000? So big. This is around 440 times bigger than sun. Such big stars are there. Sun only we can't imagine. So this bigger stars are there in the universe. So there are 7 types of star. Who identified these? Who calculated the mass of the sun? That is the important thing here. Subramaniam Chandrasekhar. It was the Indian mathematician Subramaniam Chandrasekhar. Subramaniam. What is the spelling? I am forgetting. Sorry. Subramaniam Chandrasekhar. Subramaniam Chandrasekhar was the one who calculated the mass of the sun. He calculated the mass of the sun. Based on that, we classified all this. Okay. Okay, Subramaniam Chandrasekhar calculated the mass of the sun. First person to calculate mass of the sun. He said somewhere around 1.98 into 10 to the power of 30 kg. Approximately 2 into 10 to the power of 30 kg is the mass of the sun. Okay. Mass of the sun. Okay. 2 into 10 to the power of 30 kg. And he said all those stars which are more than 1.4 times the mass of the sun, they are called as massive stars. Massive. All those stars which are less than this 1.4 times mass of the sun are called as average stars. This is called as Chandrasekhar limit. This number 1.4 times mass of the sun is called as Chandrasekhar limit. Chandrasekhar limit. It is written like this. C limit. I'll write the spelling here. Chandrasekhar limit. Okay, Chandrasekhar limit is 1.4 times the mass of the sun. See here, what is the mass of sun? 2 into 10 to the power of 30 kg, correct? 2 into 10 to the power of 30, that you put here, into 1.4. So that means 2.8 into 10 to the power of 30 kg. Any star which is bigger than that are called as massive. Any stars lesser than that are called as average and small. So this number you should remember, 1.4 times the mass of the sun. So why am I not giving this calculation? Because not required. It's geophysics. Okay. Not required for our general studies. So just remember this much. Okay. So now you will come to know this diagram. So this is Chandrasekhar limit. 1.4 times the mass of the sun. Any star which is bigger than this, they are called as massive. They will become like this. Black hole. Any stars lesser than this size, they are called as average stars. So now you write this. This is called as life cycle of stars. This diagram. life cycle of stars. Huh. So because we have different types of stars and different size, na? Because hydrogen is the most abundant element. How much hydrogen is available during the formation of star decides the size. Because you are saying like why sun is this big, why not bigger than that, right? So it all depends upon how much hydrogen is available in the nebula and how the star is formed. Huh? Huh. All stars are emitting electromagnetic radiation. Because sun is our nearest star, correct? Every day from earth, which star do you see? Sun. Because it is closest to us. Other stars are very far, many light years away from us. So that is the reason if in the night sky, you will be able to see the stars blinking, twinkling. Stars twinkle because they produce their own light. So that you can see. During the day, we can't see the stars because of the brightness of the sunlight. Okay, because of the brightness of the sun, we will not be able to see the stars during the day. But at night, it becomes dark. Then you will be able to see the stars. Okay, so please remember, all stars emit electromagnetic radiation. They are very far from us. So that comes to us in small amounts, in traces, because they are very many light years away. That is the reason we use the word cosmic rays. The light emitted by other stars are called as cosmic rays. Light emitted by other stars which reaches us slowly are called as cosmic. Planets are not luminous because our planets are made up of what? Rocks and minerals and dust. As a result, they don't produce their light. They just reflect. Planets reflect sunlight. So this diagram is the life cycle of stars. One side we have written massive stars, on the other side we have written normal stars. GKM type, this side. This OBAF. 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 So that means when our sun becomes red giant, don't you think the amount of radiation emitted by the sun will increase? Now our sun is here. All of you notice. Presently, our sun is in this stage. Slowly, the sun will enter. Because since the formation of Earth, we have already have spent 4.6 billion years. Abhogya. Sun has formed how many years ago? 4.6 billion years ago. Our solar system was formed 4.6 billion years ago. Already sun has reached this stage. Once, like after a few million years, it will become red giant. What will happen now? Sun will become bigger. So the amount of radiation received by Earth will increase. That also can cause climate change. So one day sun will pull us. Mercury, Venus, Earth will go and collide. That's the end of life. Okay. So we are going to face planetary nebula. It will take another 2 billion years for that to happen. Okay. 2 billion years. Another 2 billion years will enter planetary nebula phase. Red giant and planetary nebula. Till then we will destroy ourselves. Don't worry. We will not have to wait that long. 2 asteroids, even not even asteroid, our religious war itself is enough to kill us all. The trend in which we are going, not like Nepal. Nepal is just grain on the sand. In some atlas also they have given the photo of the life cycle of stars. This one, page number 6. Check your atlas 6 if they have given. This also check if they have given. At least some photo is good to see. You'll get an imagination how what is happening anta here. Page number 4 in some atlas. See here they have given. Please check, okay? So that you'll come to know what is happening. So if the core collapses under its own gravity, it is called as black hole. Even light can't escape black hole. Okay, so it's called as black hole. If the core collapses, if the core survives, neutron star, and a neutron star occasionally emit pulses of EM radiation, electromagnetic radiation, called as pulsar. Pulsar. Pulsars are neutron stars which emit pulses of electromagnetic radiation. Okay. So our star is what? G type. GKM. See here. These type of stars will become like this. So what is the end of sun? They will ask. If they ask you in the question prelims, our sun will become which of the following? A. Black hole. B. Neutron star. C. White dwarf or black dwarf. Like that they will give choices. So then you should know our sun is G type. It will end up as black dwarf. That is the end. If our sun was bigger, like this OBAF, it would have ended up as black hole or pulsar. Okay. So this diagram is very important. I'll show you this. First I'll show you types of stars. See here. Ours is here. See G. How many times I told you? 7. O B A F G K M. We have written that. How many types of stars? Clear to all. Sun is G type. Compare G with O. We are nowhere close. You got it? So G is here. So M is smallest. O is the supermassive star. What separates them is Chandrasekhar limit. Okay, mass of the sun. 1.4 times mass of the sun. That one. So all of you know this. So like this they have given everywhere. You can see O, B, A, F, G, K, N. That one. You can see this kind of cluster of stars is called as galaxy. So you can notice large cluster of stars is a galaxy. So most galaxies are elliptical in shape. Elliptical. Some are spiral. You can see spiral arms deviating out from the center. These centers of the galaxy, here is a supermassive black hole in the center. Supermassive black hole in the center of the galaxies are called as quasars. QUASAR. Write that also somewhere. These are supermassive black holes at the center of the galaxy. They are called as quasar. What are quasars? Supermassive black holes at the center of the galaxies are called as quasars. Supermassive black hole at the center of the. All these questions will come in the exam. Quasars, pulsar, they'll ask what is neutron star and all they'll ask. Also called as active galactic centers. Active galactic centers. AGC. Active galactic. What is galactic? Galaxic. Galactic centers. They hold the stars together. These quasars hold the star clusters together. If this is our Milky Way, sun is somewhere here. This sun is here. In the Orion arm of the Milky Way galaxy. I'll show you. Orion arm of the Milky Way galaxy, I'll show you next. Okay, this is clear. Quasars are also active galactic centers. They are in the center of the galaxy. Okay. What are quasars? You know. how a galaxy look like, you know. Okay, I'll go to the next. Wait, I'll show you. Milky Way. This topic is very lengthy. That is the reason I didn't start climate change earlier. See here, this is the Milky Way galaxy. This is the active galactic center, quasar in the center. These are called as arms. You can see arm like this. Just you are standing like this with your arm. Arms of the galaxy. Like Sagittarius arm is there here. Orion arm is here. Orion arm. Scorpion arm. Like the different arms are there. Okay. Capricorn arm is this. Different arms. Okay. You don't have to recognize. I am telling you because I know this galaxy which arm is this. So in the Orion arm we have sun. This is sun here. Okay. Let's say this is sun. Sun. Means our solar system is here. So this entire galaxy is rotating like this. Entire galaxy is rotating in the space. Okay. For our sun and the solar system, for solar system to go around the center of the galaxy once, like this, it takes around 250 million years. How many years? 250 million years. Approximately I am saying. 250 million years it takes for our entire solar system to go around the center of the Milky Way. This is called as one cosmic year. This is called as one cosmic year. One cosmic year. That means not even once we know that we have covered this. Because Earth evolution say it has covered so many times. But in our lifetime, since our evolution on Earth, we have not witnessed this. Because last 2 lakh years we have evolved as humans. And as an intelligent species, we are able to understand this. That we should appreciate. Okay. Correct now? Because no other species on planet Earth are able to understand what is happening exactly. One cosmic year, we call it as, or one galactic year, is 250 million years. It takes for the entire solar system to go around the center of the galaxy. Around the center of the galaxy. So the life cycle of sun also matters to us because that also causes climate change. This is called as cosmic climate change or extraterrestrial climate change. Now all of you know what is happening. At least you have an idea where what is happening now to the stars. I'll show you one more. Supermassive stars, what happens? I'll tell you. Supermassive. This is the diagram I was trying to write. See a massive star, red giant, supernova, neutron star, black hole. One side we wrote. We wrote this side. Okay. Then sun-like star, red giant, planetary nebula, white dwarf, black dwarf. So this is the diagram we were trying to write. All of you wrote that? Okay. Okay. So this diagram we have covered. How the nebula, how the stars are formed. So in our normal star, you can see hydrogen fuses to form helium. That's it. After that, energy is not there for helium to fuse. So that will be the end product. Then it becomes red giant, planetary nebula, white dwarf, black dwarf. But in massive stars, large amount of energy is present. So hydrogen fuses to form helium. Then triple helium fuses to form carbon. Then helium carbon fuses to form oxygen. Like that, other elements in the periodic table are formed in the stars. Where do you think we got iron from? Here in the stars. So stars fuse elements, different elements, and form different matter. I'll show you that now. So simple diagram is not there. See, this is a very simple diagram. First, the hydrogen fuses to form helium. Triple helium fuses to form carbon. As soon as they form, they keep moving out. Helium, carbon, neon. Neon, carbon, oxygen. Oxygen, neon, silica. Okay, then all these elements will fuse to form iron. So the supermassive stars we have, big stars, they have all this energy, tremendous amount of energy to fuse elements and form next element in the periodic table. The atomic number increases slowly till iron is reached. iron can't be fused. Iron can't be fused. As a result, that is the last element to be formed. You got it? So in the supermassive stars have what core? Iron core. So this explodes during a supernova. All this hydrogen, helium that is formed here, carbon and all, in the supermassive star explodes during supernova. What will happen? All that matter gets shattered in space. Everything comes to back to nebula here during supernova explosion. During supernova explosion, the core, the iron core collapses under its own gravity, becomes black hole. If it survives, neutron star. What about rest of the elements? Hydrogen, helium, carbon we saw will come to nebula. From here, new star is formed. Hydrogen is a new star. All those carbon, oxygen you saw will come to form a planet. Mercury, Venus, Earth, Mars, like that. The matter from one star goes and becomes planets for the other stars. That's how we got iron. That's how we got carbon. That's how we got oxygen. That's how we got hydrogen, helium from some other star's explosion. Now if one star explodes, the matter from that will go to some other star, forms planets around it. Okay, so like this the process continues. This we have covered in one of the starting classes. How the planets formed antali we discuss in one of the classes. Here. Quickly we'll finish this. We have time. See here I told you first because from the nebula sun is formed. From the sun all the other matter, you can see these are all dust. Protoplanetary disk is formed. Hydrogen, helium, carbon, silica, iron, all this will be here. All of them start to coalesce, clump to form planets. So this we have discussed in the starting class. How the sun was formed and gradually how all the other planets were formed slowly. So whatever dust, rocks were there here, they'll all clump together. You can see in the protoplanetary dust. This will contain what? Those minerals from the explosion. Okay. All this start to clump forming satellites, planets, asteroids, meteors and all. You can see like this because of mutual gravity. Okay. So this will become larger over the period of time, forming our inner planets and outer planets. Like this, finally like this. So our sun was formed and all the other planets were formed. So this you know. So that means explosion from some star will become matter for the next star and planets also here. Okay. So now our topic is what happens when the sun enters this phase. When our sun enters from star phase to red giant phase, then the size of the star increases. When the size of the star increases, the amount of energy emitted will increase. So then also we will experience more insolation, more shortwave radiation. As a result, the temperatures on Earth will increase. So that is the reason I called it as natural climate change. This comes under natural category. Natural climate change occurs because of our sun, because of the changes in our sun. Okay. So please remember this. So more energy emitted by the sun, more heat received. More heat received, higher the temperature. That causes natural climate change. So the climate change we are facing might be because of sun also. So that is called as natural climate change. To explain this part, we did all this. Okay. Because I have to tell you what is red giant. What is red giant? We have to cover. So I had to cover all the other topics also. So types of stars also we have discussed. Okay. So this part is clear now. Terrestrial. Some changes on Earth also can cause climate change. I call that as Milankovitch oscillation. Milankovitch oscillation. Milankovitch was a Serbian scientist. Okay, he was a Serbian scientist who gave us an idea that some changes in the planet Earth also, like our tilt, our orbit around sun. What happens when our Earth orbit around sun changes? Climate will change. Tilt, what if the now is how much is the tilt? 23 and a half. What happens if the tilt becomes 24 degree or 21 degree? Change in the tilt also will cause climate change. So that is called as Milankovitch oscillation. Okay. Terrestrial changes, natural terrestrial changes on earth can also trigger climate change. I'll explain this now one by one. Can I go to the next page? Heading is Milankovitch oscillation. These are related to natural terrestrial climate change. Climate change. He took three cases. One in the orbit of the earth, tilt of the earth, tilt angle, and tilt direction of the tilt. He considered three aspects. Any change in the orbit of the earth around sun. For example, if all of you notice, this is sun, present orbit is this. This is the present orbit of earth, present orbit around earth. What happens when the orbit of the earth changes like this? Any change in the orbit also will trigger climate change, because either earth will come closer to sun or farther from sun. So the amount of radiation we receive today will change. So change in the earth orbit. Let's say this is a present orbit, present. Future is this. What is happening now? Earth is going far from sun. As a result, any change in the earth's eccentricity in the orbit around sun can also trigger climate change. So that is said, once in many years it will happen. So tilt angle, let's say as of now earth is tilted by 23 and a half from the vertical. What is the tilt? 23 and a half. He said the tilt of the earth can change to like this. It can become 25 degree or it can become 22 degree also. Tilt angle as of now is 23 and a half. Wait, I'll write the present in orange color. Present is 23 and a half. What happens if the tilt of the earth change to 25 or 22? So then also the amount of insolation received will change. Now as of now, Tropic of Cancer and Tropic of Capricorn has been decided based on this 23 and a half degree north and south. What if the angle changes to 22 degree? The sun's vertical rays will fall over 22 degree. If it becomes 25, the sun's vertical rays will go up to 25 degree. So change in the angle, tilt angle, will also trigger climate change. All of you know that presently earth is tilted towards Polaris star. What is a star? Polaris. Today our axis is facing which star? Polaris star in the sky. As per Milankovitch, he says that earth tilt might become like this one day. We will face Vega, another star called Vega. From Polaris, our earth tilt might change like this towards Vega. So that also causes climate change. He predicted three changes for climate change on earth. Change in the earth's orbit, that is called as eccentricity. Means how eccentric the earth can be. So write these three. I'll show you this online, then you'll be able to write better. Milankovitch cycles. You see, first I showed you orbit. Earth orbit changes once in many lakh years, as per Milankovitch. Then he said our tilt can change. That is 23 and a half, 22, 24. I wrote a lot. 22, 24, like that. Tilt of the earth can change. Okay. Then precision. Now it is facing Polaris. It can tilt towards Vega. Okay. Another star, North Star called Vega. Now it is facing North Star Polaris. So tilt of the earth can change. So he also gave some timeline. This can happen once in few years, thousands of years, 25 years, 25,000 years, that 40,000 years, 1 lakh years. Means over the period of time, Earth orbit, tilt and tilt angle, everything might change. So these are called as Milankovitch cycles. Like this, there are so many images online. You don't have to worry. So many images are there. Here also, see. This is clear. Here you notice orbit, changes in the orbit, changes in the tilt angle, tilt, changes in the direction of the tilt. Okay, see here Vega. Now it is Polaris. It can turn to Vega. So he said Earth tilt can change from 22 to 24. Presently it is 23 and a half. Okay. Milankovitch cycles. These are called as natural terrestrial changes. Any change in the Earth orbit tilt can also trigger climate change. So as of now, Earth's tilt is 23 and a half. Okay, I'll write that. Present tilt of the Earth is 23.45 degree actually. As of now. Most of the books they have given 23 and a half, correct? Most of the books they are saying 23.5. But actually accurate one is 23.45. 40,000 years ago it was 23.40. 40,000 years ago. Now Earth is tilting how much? 23.45. Another few years it might become 23.5 exactly. Then it might change to 24. Another 40,000 years ago. So as a result, now climate scientists are saying, so the precision of the Earth is changing. Earth obliquity is changing. Please write this down. This tilt angle, obliquity, tilt. This precision, which way? So direction of the tilt. So these three are called as Milankovitch cycle or Milankovitch oscillation. So anyhow, we have started this topic. So all of you know, natural reasons of climate change is one is extraterrestrial related to our star, other one is terrestrial related to Earth, change in the orbit. Next comes anthropogenic. So you check your notes please. Global warming I have given, greenhouse gases and global warming. I have given the list of gases and also I told you global warming potential and all I was mentioning. I'll repeat again. But I want you to check your notes of these gases I have mentioned. Greenhouse gases. I have mentioned some list of gases which we are releasing. Carbon dioxide, methane, nitrous oxide, chlorofluorocarbon, hydrofluorocarbon, sulfur hexafluoride. Remember? SF6, perfluorocarbon. I showed you the global warming potential of these gases also. How much harm they can do. I was showing you SF6, how much potential it has, and I have given the list also. I remember in one of the class I told you this is going to be useful, and one list I have given of these gases and the impact they can do, damage they can cause. Correct? Many of you have written. Source where they are released also. So those comes under anthropogenic climate change because we are also responsible for climate change. Okay. in a small scale, we are releasing large number of gases since industrial revolution of 19th century. As a result, 19th century onwards, we have increasing our fossil fuel consumption, coal, oil, natural gas. We have increased, population has increased. We have cut down a lot of trees, forests have come down. Correct. As a result, carbon dioxide concentration has increased. Manufacturing of many new goods has led to release of SF6, perfluorocarbon, hydrofluorocarbon. All this have increased. We have released large amount of methane from paddy field as well as from livestock. We have increased our livestock population also, cattle. So methane has increased. So all these greenhouse gases are responsible for anthropogenic climate change. Anthropogenic climate change. Okay. So if these gases were not there, let's say it was limited, or if they were in a certain level, so the anthropogenic climate change wouldn't have taken place. Okay. So anthropogenic climate change is taking place because of our sudden increase in human population. Okay. So that I'm going to discuss now. So do you have time? Almost like 1. Tomorrow we have class. Tomorrow's class will complete this anthropogenic climate change, impact of climate change, climate conventions and all will start. Some of the conventions I will cover in environment class. At least we will discuss impact of climate change and our response. Okay. Tomorrow's class. And I'll start with oceanography. We were supposed to start today, but it's okay. Because science and technology teacher will not cover this. Space, they will not cover. Already covered? No, I know they will not cover. So, in case if they cover, let them cover. Okay. SNT teacher will have to, but usually they will, since already done, they will say. Any doubt? Okay. Today's class we have done from page 79. What did I say? Whatever we have covered today. 79. Jet streams. Geostrophic wind. They have given. Geostrophic wind. 1. Then 11th chapter, World Climate and Climate Change. Köppen's classification given, and behind that they have given climate change. Causes of climate change, they have given all this, whatever I have mentioned. Okay. Milankovitch oscillation, greenhouse gases, global warming. Please read. Page number 95. Page number 95. Okay. Chapter 11, 95 page number.